So, good morning everyone. So I'm Rafael, this is Anton. We work for the Swarm team. We are kind of mainly responsible for DevOps related tasks and also testing Swarm. And testing Swarm is not that easy. Even a big part of it is observing how Swarm is behaving. And this presentation will explain you some techniques that we apply during our testing process.
So I'm going to start a little bit with observability and basically cover the tools and the techniques that we use to debug Swarm. So most of the observability tools like logs, metrics, tracing, they have been parts of the Go Ethereum code base for a long time. And we've had them over the past few years. So what we've done over the last year is basically include them in our automation tools so that they're available to everyone who develops on Swarm and they can get meaningful signal out of them. So the first part of the observability tool set is the logs. So Swarm pushes logs to the standard output. You can set different verbosity. And also include the call site location of all the log lines. It's quite useful to bump the verbosity up from the default value of info so that you get also log debug and trace logs and understand what your Swarm node is doing when you're running Swarm. Metrics are basically pushed into time series database where we aggregate them from in the distributed environment, and we can actually visualize what a Swarm network is doing, not just one node. So basically, we aggregate logs within our deployments with Elasticsearch and visualize them with Kibana. We will be showing this later in the presentation so that you see how we do this on a day-to-day work. And metrics, we aggregate them within InfluxDB, and we have dashboards in Grafana where we visualize basically different counters and timers so that we have an idea of how performance Swarm is and what part of the protocols we need to optimize and whether things are just working correctly. It basically gives us an overview of what our nodes are doing when we run different test scenarios on them. We also have tracing, and basically the flags that you need for that are the tracing flags of Swarm. We're using the Open Tracing Framework. Most of our internal APIs are already instrumented, so you have the possibility of adding traces and log lines within any part of the code base and then have them visualized in this central system for which we use Jaeger from Uber. And that also gives us another system to basically have visibility over our networks, private deployments, and testing in general. This is what Jaeger looks like. Here we've just visualized an HTTP GET request which goes through the internal APIs of Swarm and also goes to multiple nodes. So from node 16, we communicate to node 3 and node 29, and basically the timings of those requests. So next I'm gonna give back the talk to Rafael to tell us a bit more on what we basically improved over the last 1 year.
So, deploying Swarm, in the past, so what we did is many times we deployed Swarm on our machine. We would use, for example, containers to deploy multiple nodes on a single machine. Then of course you have the bottleneck of your machine. You don't have enough memory, you don't have enough CPUs. At one point in time it gets slow, you are just able to provide a cluster of, 10 nodes, and that's it. Also, on our public gateways, in the past we've used some virtual machines on public clouds, AWS, and we used Ansible to configure these machines. This didn't really scale very well. There were many manual steps that we had to do, adding VMs and then running the Ansible scripts manually and so on. So we have improved this. yeah, I mean, here are the problems mentioned that we had. And basically what we did was we started using Kubernetes. Kubernetes, for those that don't know, it's just like a container orchestration tool. So you just have like a bunch of servers and you just orchestrate like applications. You say like run 100 nodes of these, and that's mainly it. So it makes like this whole automation process easy for us. And in Kubernetes you have a thing they call it Helm. Helm, you can see it as a package manager in Kubernetes. So imagine if there's like a package Swarm, which we actually did develop this. You can like install Swarm in Kubernetes and just configure it as you want. And so this Swarm Helm chart, that's what it's called, it provides a lot of configuration, and it has like everything integrated that we've mentioned before. This means like the metric stack, like InfluxDB and Grafana, the tracing stack with Jaeger, and also like the logging stack. Like it's all in one chart. So it's just really the one single application that you deploy and configure, and you will get like everything out of the box on your cluster. Additionally, we also have some smoke tests. Smoke tests, you can see this as some like essential basic tests that in the case of Swarm, they just periodically upload some files and retrieve them, and we even gather like metrics from these so that we can see over time how the cluster is behaving if we keep consistently like uploading files to the cluster. Yeah, as I've mentioned, this is what our Swarm Helm chart looks like. So we do actually have Swarm itself as an application there, and then we have like all these dependencies that are nice to have everything working like from scratch. The metric stack, which is InfluxDB, and Grafana like to visualize, and Jaeger like for the tracing stuff. And actually also now, since we have swap and like incentives, it's not here, but there's another component that we've added like for testing purposes, which is there should be also a how is it called? A ganache. So we use ganache like to simulate the blockchain and connect our Swarm nodes to it. Yeah, now I'm handing back to Anton. He's gonna show you actually a live cluster that we have deployed, and he will go through like all the things we've mentioned.
Yep. About the Helm charts that Rafael mentioned, all this is open source, so anyone is free to check out the repos. And yeah, basically what I'm going to show now, everyone is basically free to run it on your own clusters or even on your local machine to have a look. So let me see. I guess I need to make this a little bit bigger, and let's hope that the internet works. So basically I'm just showing the pods of the deployment that we started yesterday, and we see that it's like a 50-node Swarm deployment, and we've been running some periodic smoke tests on this deployment. And basically in order to get this, what you need to do is basically just provide one YAML file, which basically specifies that you want to make a Swarm deployment based on the Swarm chart, which is open source, the number of replicas that you want, and then basically this deploys Swarm for you. If it also comes bundled with the debugging tools, so I'm going to show you those. The first one is Grafana. So we just pour forward to the Grafana instance on the cluster, and it takes a while, and then we can open it up in the browser. So we basically see automatically we get all the dashboards that we are using in the Swarm team. You don't need to import anything or set up data sources, they all just come here. And this is the default Swarm dashboard, which gives us an overview of the warnings, errors, debug lines, the uptimes of the nodes, the HTTP requests, etc. We can check also some other dashboards, for example, the smoke tests. So the smoke tests over the past, let's say, 12 hours, we can see that we are periodically uploading and syncing, with also the chunks that have been synced across deployment runs, and the other useful information. For example, in the stream dashboard, we have information on the syncing protocol, the main pool syncing protocol of Swarm, the number of peers per node, the received chunks, the offered chunks, the wanted chunks, and basically a very nice overview across the whole deployment of the various protocols. So that's pretty much what Grafana gives you. It basically visualizes all your metrics, and the nice thing is that it's available immediately when you run your Helm chart, and it comes bundled with all the dashboards that we're developing on a daily basis. So the next one I'm going to show you is Jaeger. So basically this is the distributed tracing, so we're going to port forward to the Jaeger service. And for that I also want to see the last smoke test that run, so that we can visualize something that just run. And we see here that we uploaded successfully to node 0, and then we fetched it successfully from node 4. So I'm going to just check this request from node 4, and this broke because I just killed the port forwarding. And we go to Jaeger. And we look into basically the request that we are kind of interested at.
Let's pray for the demo gods all. Yes, thank you.
And we can see that the request is like from 9:50, 9 minutes ago. And we can basically see all the buffer grids on this HTTP GET request. The reason it's sequential is because we support range queries, and you can actually just ask for a chunk of that content, but we're uploading and downloading the whole thing, so we see all of them. And within those individual read buffers, we can see the remote requests and also the local store requests. So the local ones are those chunks that we have on the local nodes. The remote fetch ones, I'm not sure if you see that, are basically those that go to remote nodes. So in this case, we see that node 4 asked node 33 for a chunk, and we can see for which chunk it asked, when that happened, how long it took, etc. So as an overview, we check what happens within a deployment, and we measure 95 percentiles, 99 percentiles across the whole deployment in Grafana with the metrics, and within the distributed tracing, we have a more in-depth look over specific requests. So much about distributed tracing and metrics. The next thing I want to show you is the logging setup, which basically we use Kibana and Elasticsearch to aggregate the logs. And again, I'm going to port forward to the Kibana service. And there we can filter for anything that basically is mentioned within our logs on any of the nodes. So this setup is aggregating logs from across our whole cluster, which means that all deployments are sending logs. So I'm just gonna look at all the logs of the last 15 minutes within the Swarm private 0 node. And we see all the logs here. Why this is useful: if we search, for example, for HTTP request, we can see, for example, this request and search for one individual request based on its request identifier. And we can have, again, all the information about the specific request to a specific node that we have identified as interesting. So we have the call stack location and the request, basically. So that's quite useful when you're developing the protocols if you want to debug what's pretty much going on within your deployment, and it comes out of the box when you deploy a Helm chart. So with one command you get those 3 systems, and it helps to build on top of Swarm. So that's pretty much it.
You can also show the ingress.
You want to show that?
Yeah.
What's the command?
kubectl -20 get ingress.
Yeah.
Yeah. So also with another thing we have, so Swarm has the HTTP interface, and we automatically have like a reverse proxy that generates like these host names, and they are publicly accessible. So we can target any of these nodes like through our browser easily. And yeah, this is just targeting one of our nodes. Or we can just load balance through them as we want. And everything out of the box. Now you can play. We mentioned like large-scale deployments. We just showed like a 50-node cluster, but this also works for more nodes. The biggest one we demoed, I think it was 1,126 nodes. So that's it. There's also a list of useful links we've put here. So there are our Helm charts. If you know about Kubernetes and want to try this out, just have a look at the Helm charts. And yeah, that's all. Thank you very much.
Any questions?
Where is it deployed?
This is deployed on Kubernetes on Amazon. So we're using Amazon for our development, but it can very well be on Azure or any other cloud provider. Or Kubernetes, you can deploy it on your local machine as well, or on your own hardware. It's quite transferable across any type of hardware. Thank you.
Yeah, thank you for that. So, this is actually a really big deal because when we are running a single Swarm node and things don't go right, it's sometimes really hard to know what's going on in there. And we used to have like log dumps, and you can try to figure out what's going on. But what these two have done is not just made these logs really nice and you have graphs, you can see things going on. What they were just showing with that distributed tracing is you get to see what's happening in the entire cluster. Somebody makes a retrieval request, and that gets passed from one node to the next, to the next, to the next, and you can see the logs going all the way through this. So that's a really important thing, because when we're developing something like Swarm, which is a peer-to-peer dynamic network, you're not only debugging what a single node does, you have to get the emergent behavior of the entire network correct. And that's hard because you get really sometimes very subtle things changing, having big influences. So that's why this was really great. So if you're into DevOps, look at what they've done. Look at the repo. You get a lot of really cool tools. So yeah, we've rescheduled a bit. That was Anton Rafael. Victor's talk we have at 10:40. The next talk coming up is from Wojtek and Rinke. They're right here.